Disclaimer. This presentation session was prepared or accomplished by Cupid Chan in his personal capacity. The opinions expressed in this talk are the author's own and do not reflect the view of any United States government agency or department.
Good morning, good afternoon, or good evening, depending on where you are geographically located, and welcome to the DataCon LA 2021. My name is Cupid Chan, and today we are going to walk through a topic about Catch Me If You Can, how to fight fraud, waste, and abuse using machine learning and machine teaching. A little bit about myself. I'm the chairperson of BI and AI Committee in Linux Foundation. And a little bit history about this foundation. It was actually called ODPI before, and then last year we combined it with LFAI, another AI community, to form an even bigger LFAI and data committee. Why do I tell you about that? It's because this talk about machine learning and machine teaching is a result of a paper that we published last year about human-centered AI, which I'm going to walk through you later in this presentation. But first of all, let me share with you a story about myself when I prepare for this presentation. One night in the LinkedIn, I received an invitation from someone called Jacqueline Moss. I don't know her, I never heard about this name, but I noticed that there are 16 mutual connections in LinkedIn that also know about her. So that's why I accepted the invite and then continue to have some chit chat in the message with her. And then things start getting funny and interesting. When she asked, okay, what do you do? I said, I help organizations to leverage data they're using and AI by AI and analytics. For example, in preventing fraud, waste, and abuse. You know, I told you, right? I was preparing for this presentation. And then she keeps on going and say, interesting, I would like you to share with me in exclusive about yourself. To be very honest, I don't really understand what exclusive means, so I ask, by exclusive, you mean in what sense? But her answer is, yes, exactly. So, I'm sorry, but exactly what? So, I promise you this LinkedIn story to be continued. But back to the topic for today, Catch Me If You Can. I'm not sure whether you, but Catch Me If You Can is actually one of my favorite movie all times. In the movie, Leonardo acts as a pilot, but he never attend flight school. He is a doctor, but he never attend medical school, and he is a lawyer, but he never attend law school. Just like any regular movie, if you have a bad guy on one hand, you will have a good guy on the other hand. In this case, Tom Hanks is the good guy. So if I can just readjust my title slide, maybe this is a better title slide. Catch Me If You Can, How to Fight Fraud, Waste, and Abuse using machine learning and machine teaching. And because of this topic, I try to research, is this fraud? How are those people, how are the companies are going to tackle fraud using different technologies? And then I find out that Forbes did a survey 2 years back about how different organizations will use data and analytics or technologies to fight fraud. And here is the result. I want you to focus on here, artificial intelligence and machine learning. Yes, it's not the highest, it's actually one of the lowest technology here, but look at the yellow line here. It actually has the largest adoption rate predicted in the next 1 or 2 years. So that's the reason why today we are going to look at how AI machine learning really fight fraud in that sense. When we are talking about fraud, there are different types of fraud: credit card, healthcare, or identity fraud. Out of the three, which one do you think has the highest number of fraud in terms of the dollar amount? It is healthcare, $68 billion per year. You may wonder, wow, that's a lot of money. But hold on until you see this number. Centers of Medicare and Medicaid Services, in 2018, it has over $1 trillion of the annual budget just one agency. If I put this number, rank it in the GDP, it ranked approximately 17. One agency, it's actually comparable to the budget of the GPT of 17 largest country in the world. In fact, that's also one of the reasons why, but the larger, the bigger of the money, of course, the theft will actually be attached on that. So that's why a few years back, ABC News also has an episode about how Medicare funds are actually improperly paid to some fraudulent, approximately $16 billion in terms of the amount. And if we agree this is a big problem that we need to tackle, the next question that we may have is, how can we get the data? Where is the data located so that we can start analyzing and find out using AI machine learning to do that? But the problem is, those kind of data sets not only is not available, if it is available, usually I think it would be proprietary because people will spend time and try to label what is fraud so that we can apply machine learning. Fortunately, in this case, CMS also released a data set for public use. It's called Medicare Provider Utilization and Payment Data. And in this data set, you can see that it has different years of the provider spending pattern that we can leverage. And when you look closer to the data, you will find out that we cannot just use it out of the box. And just like any data cleansing, there are something that we need to identify. For example, in this case, some years have certain attributes or metrics those are not really carry on throughout all the years. And in some cases, some data are not really useful in our analysis. So after reviewing this kind of data set, we find out that only those numbers that are matching should be used. And those highlighted here are the ones that require either harmonizing throughout different years because of the names are different. So for example, you can see that MPI here sometimes is lowercase, sometimes is uppercase. And for example, here in the lower part, you can see that they basically are not there available. So in order to cleanse it, we need to make sure that all this red box here are get rid of or taken care of so that the data across different years can be harmonized correctly. So this take care of only part of the equation, because when you think about this data provide feature, but in order to make the machine learning work, we also need the label. And in this case, Office of Inspector General, OIG, released another data set that we can use to join together with the utilization data set that we saw from CMS. In this case, the list of excluded individuals and entities, LEIE, has a list of providers or doctors. They misbehave and then been proven by the other evidence that he or she should be excluded from the government program because of the misbehavior. And the result is, starting from certain period of time, he will be excluded from the program until maybe the end of time for this exclusion period. So that means one thing. If we can find he or she still charged the government program in the utilization data set within this period, it is a fraud because he just should not and cannot charge for that. And then on the other hand, I think it's very important. What important is, it's not like at this point he commit crime and then he being barred from charging the federal funding. Sometimes before this time, I would say maybe 1 year before the excluded day start, they start to do something fishy that catch the OIG's eyes and try to start the investigation and ultimately convict him at this point. So what do I want to say is, we define fraud is 1 year before the excluded date starts until the excluded date ends. And for this doctor with this NPI, any HCPCS cost, any charge that happens and we can find in the utilization data set, we define that is a fraud. So when we combine this together, this is the picture. We combine different years into one centralized thing like this, so that we collapse and harmonize all the years together for the utilization data set. That provides the features. And then here in the LEIE data set, we combine together using the MPI so that we can label whether that transaction in the utilization data set is a fraud or not a fraud transaction. So this is how we are going to use that as the input for the machine learning. So if we move forward and try to build this, someone may take weeks or days or weeks to train a model and come up with something to predict the fraudulent case. But because of my experience in AI, I can assure you, I can build a model guaranteed 99.9% accuracy rate within just 10 seconds. Are you ready for my model? My model is everything is not fraud. Okay, some of you who know data science would know that I'm cheating because I said accuracy. And accuracy is only one of the many metrics to determine how good or bad a model is. And in this case, take a look at the data set. We have about 54 million different rows here. And out of which only 4,000 something is considered as fraudulent case. So if I just blindly say that everything is a fraud, I am attending more than 99.9% accuracy, because it is considered, this is defined by total number of cases that I can predict it correctly, without considering that the case here is to catch the fraud. And in this case, fraud is considered as a minority class. And this actually is a very common and a common scenario, a popular scenario. Something like credit card fraud, manufacturing defects, or rare disease, or even natural disasters, right? Usually that would not happen. But when it happens, it's something really bad that we need to catch. And if we just allow like someone like me how to trick the model and claim the accuracy, or even if we just let the model to run and come up, the algorithm to run and come up with a model, the model will still be biased because the model see a lot of the majority and just a tiny little for the minority. So in this case, how shall we change, or what's the approach that we can fix about this issue? We are going to use something called decreasing majority. That's one of the approach. When the majority is a lot, how about cut it down so that it will be comparable to the minority, so that when the algorithm try to train the model, it will not be biased and keep saying that the majority is the prediction and the result. On the other hand, besides decreasing the majority, we can also increase the minority to make the minority more so that it would be more comparable to the majority. That is another way to think about how are they going to be trained without so much bias. And when we look at that, the way that I'm going to use is random undersampling. That is reduce the majority. Why is that? Because look at the numbers. I have already got 54 million of cases that we need to train. I actually don't need even more. Indeed, I want smaller chunks so that in the training process, it will be more effective and efficient. So I can cut it down. I can cut down the normal to be 50-50, around the same number as the fraudulent case, or 40-60, 30-70, or 20-80. The bottom line here is I need to bring the two sets, the minority and the majority, to be a more comparable way so that when the model and the resulting model will be more effective to detect fraud. What is the result then? Let's look at that. I used 50-50 class distribution, which means like the minority and the majority will be approximately the same. TensorFlow boosted tree classifier is the algorithm that I'm going to use. The resulting model, look at that. Accuracy is 76%. Yes, you're correct. That's much, not much, but lower than the 99.9% accuracy. But see, the precision and also the recall, they are pretty decent. They are pretty okay. And look at the AUC, the area under the curve, is 84. So in general, this, even though we sacrifice the accuracy, but this model is much more useful than just blindly predict everything and anything to be fraud. And this is called supervised learning because we have a set of feature, and then we have label, so that the model can train based on the data pattern, but there is a limitation for that. What's the limitation? Number one, the tag data, the label data is not always available. In this case, we find a way to combine the other data set and try to categorize them as the fraudulent data versus not, but that's not always be the case. And secondly, if there is a new emerging anomalies or a new way the bad guy are trying to trick the system, then supervised learning may not be an optimal way because it has to have certain label in order to catch that trend. So in this case, we introduce another type of machine learning called unsupervised learning. It's very good to detect outlier, doesn't need any label to be in place. But remember, detecting an outlier, the outlier is only a suspect. A fraud is criminal. So once we detect the outlier, we cannot make any conclusion, but we still need more evidence to prove that is a fraudulent case. Let me give you an example and see how this unsupervised learning works. Look at this. Can you please tell me, across this, I basically plot the data in a graph like that. Can you point to me where is the outlier? That's very hard to do that because it's not oriented to pick the outlier. But look at this one, the new one. I picked the XY axis in that sense, and you can immediately see that the outlier is right there at that dot. So in this case, because I oriented the data in the way that I can easily see what is the anomaly. So the trick for unsupervised learning is how can we view the data in different fashions so that the outlier will pop up. And this is one case. But let me show you another example. I know that this is a remote conference, but I want to introduce more interactivity with you. And in this case, I have P1, 2, and 3. Can you please maybe put your finger right there on your screen and tell me which point do you think is considered as outlier? I give you 2 seconds. Ready? If your finger is pointing to P1, congratulations, you get the answer correct because P1 is an outlier based on the nearest neighbor approach. It's by measuring the distance from this point to the other neighbors, which one has the the furthest away from the other neighbor, that is considered as outlier. But if you put 2 fingers, one on P1 and the other one on P2, your answer is even more correct, or you are taking care not only the nearest neighbor approach, but also the density-based approach. Look at the density around P1, of course, like there is not much around this point, but P2 is the same compared to P3. As you can see here, are surrounded, the density is around the same. So P3 may not be an outlier, but the density of P2 compared to the neighbor right here, P2 in that case, it's considered as outlier. It is very helpful, especially when we want to cluster different groups together. And in this case, as you can see, by grouping by density, we can roughly see that there are 3 different groups on this data sample. And whenever I am thinking about unsupervised learning and how this data are going to be clustered together, I always think of this video. Take a look at that. Can you see what are they? If not, that's normal. But let's take a look now.
This may look like just a jumble of old painted plastic and wire, but when you take a step back, you see it for what it really is. A remarkable sculpture suspended in mid-air.
So when I think about unsupervised learning, my vision is exactly like this. Data is already there. It's hanging there. It's just a matter of which angle shall we step back or step forward in order to capture that pattern that you can see the outlier. That is the mental picture I always think if I am thinking about unsupervised learning. So now, let's go to the third approach in machine learning and see how is it going to fight fraud, waste, and abuse with this third approach. But I cannot miss this person if I'm going to introduce you this third approach. Who is she? So I have 3 choices here and see whether you can get it right. Number 1, she committed a 100 million fraud in a European bank last year by guessing the admin password using an AI algorithm. Number 2, she's actually a man dressed in disguise to fool the airport security, smuggling 500 fake passports in US last year with valid passport numbers produced by AI. And third, she is the person inventing this third approach of AI algorithm. Which one do you think she is? You ready? The answer is none of them. Indeed, she is not even a real person in the world, but is generated by this third approach. And this approach is called Generative Adversarial Networks GAN. It's a semi-supervised learning. So when we saw the other 2 approaches, we know that we have only one model produce the result. And in this case, I have 2 different algorithms work together against each other. The generator will gather and try to study the real sample data from the real world, and then try to produce some fake samples. And then, on the other hand, the discriminator will feed the discriminator by the real sample and also the fake samples generated by the generator. And then the job for the discriminator is find out, hey, yes, it is fake, or no, it is not. And then based on how the result is provided by the discriminator, we feed it back so that we fine-tune both the generator and the discriminator to make both model being smarter and smarter. In this case, how about we swap the real sample with the picture, and then the generator will keep on producing different pictures, and for the discriminator to identify whether it's a fake or not fake picture or real picture. All right. So the end result usually, when in the traditional way when we use this, the end result is we are going to throw away the discriminator and keep the generator. And that is how that lady that we have just saw a few slides back is produced, because we are trying to keep the generator. As the generator become better and better, then it's basically can fool the discriminator 100% of the time. And when I am going to explain that using this graph, it's like, look at the blue cross right here. Those are the real thing. And the yellow circle or yellow dot here are the bad guy, right? So when we are trying to generate the sample, we are generating the sample around the actual real good thing right here. So that's the bad guy. When the generator trying to generate more and more, of course, that will be blended together with the actual benign users. In this case, the discriminator will become, I don't know, it's because it's so close to them, right? So that's why when generator create a picture, in that case, there is no way for the discriminator to determine whether it's a real picture or not. But you may ask, hey Cupid, we are talking about fraud, waste, and abuse, right? Why are you going to talk about picture generation? I'm going to answer you like that. By switching the generator and discriminator with Leonardo and Tom Hanks. In this case, I also switch the cat's image with a real check. And then the generator, of course, will produce the fake check. And the job for Tom Hanks is to determine whether it is a real or fake check. And then here, the difference is we're not throwing away discriminator. We're actually keeping the discriminator. Because that's basically what we want, right? We want to determine whether this is a fraud or not. And the way it works is instead of using the regular gang, we are using a complementary gang. Instead of trying to mimic and produce something blended with the benign user, we are trying to produce something in between the good and the bad. So that when the generator trying to generate something in between, then the discriminator has to learn very smartly. So in this case, when the generator generates this, there is a blurred line here, then the discriminator has to be very smart in order to detect it. And this is the principle of how we can leverage gang to fight fraud, waste, and abuse. To keep the discriminator instead of keeping the generator in the regular gang. So now let's take a look at a recap and see what we have talked so far. So we talk about the supervised learning. As you know, we need the feature and also the label. Unsupervised learning, we only care about the feature and let the algorithm to determine what's the pattern. And semi-supervised learning, such as scan. But look at that. They are all learning. Just like a healthy education system, learning is only part of the equation, right? On the other side, how about teaching? Teaching is also very important in an education system, just like we know that every day. And remember, I told you in the beginning of this talk, we in the LFAI and data community, we are actually have a publication last year, talk about human-centered AI. One of the topic is actually talk about machine teaching. But before I dive into that, let me show you this. I have another video in YouTube called A Iron Chef. How are we going to use AI recipe for the data kitchen? In that video, I depict all different steps that the data scientist or the data engineer is going through step by step until the end result can produce and benefit us. But you can see here, when human is going to involve, it's very silo. For example, the data expert or the annotator is going to maybe annotate the data in the data gathering process, and maybe in the end, when the results are there, the end user may provide some feedback and then just basically gather that result to enjoy the service provided as the result of the machine learning. So it's pretty silo. Human doesn't really interact for this process, the machine learning process. If we really want to put human in the center, what do? We first reorient it. And in the old way, we use brute force to annotate the data right here. And then at the end, the service provided at the end of this machine learning will be consumed by human. But what if? What if we introduce something here in the data input? So instead of human use brute force to annotate the data, we use machine to learn the data, and it will, when it has doubt, it will come back and say, for example, in this case, the machine would know, hey, I know the cat has pointy ears, but I found something, I'm not quite sure. So in this time, human will step in and then say, hey, it's a chihuahua. It's a dog, it's not a cat. So the machine then will now understand, okay, let me update my model to recognize this is actually a dog, not a cat. Human teaches by interacting with the machine in the data input, so annotating with the correct data. On the other hand, when the output is ready, so making appropriate decision, what happened is when the machine, let's say it finds, hey, I see unusual claims for Dr. X this year, especially the number, it just jumped 25% of the number of patients that he used to see against the 5 years running average. It's not abnormal. Then the human, us, can step in and say, oh, okay, you know what? Your model is based on something that you don't know because Dr. Y is actually having a maternity leave for 9 months, so that's why Dr. X picked up her patients. So that's why in the interim, the number of patients just jump up. And in this case, human collaborate and teach in the decision making. So this is the overall picture of how can we really put human in the center, human-centered AI in machine learning and also machine teaching. And let me give you an example, a real example of how really this is going to work in the real life. Look at that. I think the best way to incorporate machine learning and machine teaching is to put them together in one single place. And in this case, as you can see, I have the fraudulent case predicted by the machine learning model. But at the same time, I also have another thing on the very same interface to let the users to determine whether, yes, your prediction is right, so I confirm it, or no, sorry, this prediction is wrong because of some other things, so I can decline it. So based on that, not only we will get a model as a result of machine learning, but because of this feedback loop, the machine will also learn from the feedback from the human. So it's the machine teaching piece right here. This is the machine teaching piece. Feed it back to the system to close the loop. And I think this is also the result of and the direction of what shall we go in order to make the more complete AI approach in the organization. So long, that will be the almost the end of my talk. But let me tell you or continue my LinkedIn story. After like a few more minutes, I decided to find my most knowledgeable friend for help, who is Google. I type in Jacqueline Mars, and who is she? She is actually a real person and living in Virginia, as she told me. But the problem is, she is approximately or even over 80 years old. I doubt an 80 years old ladies will be as aggressive and active in LinkedIn and try to connect with me. I highly doubt it. So that's why when I reply, you can see that I'm sorry, exactly what? That was the conversation left behind, right? So she continued, okay, what do you do in your place of work and how profitable it is? I said, I see. And then you know that when you put your mouse or cursor in the message box, you will have something like Cupid Chan is typing. In that case, you know what? I'm the one just hang there. She is the one hang there. I'm the one that put the cursor there. So now it's her turn, feeling like, don't you want to talk to me about this? It's fine. I'm sorry. So in order to keep her interest, I just copy and paste my profile in LinkedIn and put it here. And then her response was, wow, cool. So I continue to prepare my presentation as I told you. Didn't really realize anything, but I just wait for her to see if there is anything, she will come back. But then I suddenly remember, hey, she has 16 mutual connections with my friends in LinkedIn. Let me check who are those 16 friends also connect with her. But when I click on that profile again, I find out this profile is no longer available. Maybe someone just reported to her, maybe because it's because of the LinkedIn algorithm detects that she is a scam. I don't know. But fortunately, I captured all the conversation that I had with her so that I can show you. The whole point I want to point it out here is, even in a professional, like a social network like LinkedIn, there are still chances of having fraud there. And then in the real world, remember the movie Catch Me If You Can? In fact, the real Frank Abagnale turns to a good guy after being caught by FBI and served in FBI using his knowledge to find different fraud and bad guy in the past 40 years. But in reality, not many people are going to turn from the bad guy into a good guy. So while we are talking the topic of Catch Me If You Can, how to fight fraud, waste, and abuse using machine learning and machine teaching by me, maybe on the other side of the world, there are other people talking about similar topic. Catch Me If You Can. How to fight, not fight, but how to conduct fraud, waste, and abuse using machine learning and machine teaching by some anonymous hacker. So doesn't matter it's a good or bad morning, afternoon, or evening, someone geographically located on the other side of the world could have the similar topic like this. The goal, the whole spirit here is, if we are not adopting this technology to fight against it, we will be the victim, suffer from it. And that's pretty much my talk today. Again, my name is Cupid Chan, and please, I urge you to subscribe my YouTube channel, because for today, I don't have much time to describe in detail on each section about supervised and semi-supervised learning. But my plan is in the next few weeks, I'm going to keep on sending or uploading this kind of video and investigating those topics in more detail. So if you're interested in know more, how did I achieve those results that I share with you, feel free to subscribe my YouTube channel and link in me in different channels so that we can get connected. But besides that, I hope you continue to enjoy the content of the rest for this conference. See you later. Goodbye.